Hi, welcome to Half Angle Identities. This is the final part of our identities sheet. They are kind of the trickiest to look at, but they follow a lot of the very similar rules that we have been seeing so far this chapter. So let's take a look at those identities. They do look pretty gross. I'm not going to lie. They're pretty gross looking. Something to note, sine and cosine have this plus or minus. You need to be careful about when you decide whether you should be using the positive case or the negative case for these problems. We need to choose that plus or minus based on the location of theta over 2, not where whatever this theta ends up being. So to give you an example of where that is happening, take a look at this example. We know what the cosine of 60 degrees is. It's 1/2. It's cosine of pi over 3. That's 1/2. Done. Boring. If we were to do this using cosine half angle, we would do all of this work and we would get to this final spot. We're doing the square root of 4 and we get 1/2. But how do we decide if it is positive or negative? If we used the 120, 120 is in quadrant 2 where cosine is negative. We don't want that. We wanted, because we know what this cosine of 120 over 2 should be positive 1/2. So we want to say, okay, well, where is the theta over 2? Our theta over 2 in this case is 120 over 2, which is 60. So where is 60 degrees? 60 degrees is in quadrant 1, and in quadrant 1, cosine is positive, so I'm going to use the positive case for this question. That's why this plus or minus just sort of drops out. We wanted the positive case for this problem. If you wanted to see this one in its entirety, we're going to do one in just a second. But there's this problem in its entirety. So be sure with sine and cosine that you're choosing it on the location of theta over 2. Now, with tangent half angle, I've got some notes about this one. So cosine double angle, we had like 3 options. And I'm like, yeah, use whatever. It's fine. You do you, man. You choose whatever you want. Not so much this time. This one is great. I love this one. 1 minus cosine theta over sine theta. Works great. Love it all the time. What if you're like, I've used that one so much. I'm so bored with it. Well, fine. I mean, if you're feeling a little frisky, you think this one's boring, you can use this one. That's fine. That's fine. No problems. This one, use it only if you hate yourself. If you hate yourself, you can use this one, but otherwise don't. You might need it in some particular proofs. That's why I left it on here and available to you. But unless you're forced into a corner or you really hate yourself, don't use this one. Use this one. It is great. This is the best one to use. It makes your life so much easier to work with. And you'll see why soon. But this is the best one. This one's okay if you're really feeling a little crazy. And this one's horrible and it's bad. So let's do a sample problem. So we're trying to figure out what the sine of 22.5 degrees is. I don't know what that is. 22.5, you kidding me? I don't know that. Well, instead of trying to figure out that 0.5 is kind of screaming at me, oh, I should do like a half angle thing. So I say to myself, okay, self, if I'm doing half angle, sure. So I say, okay, well, what divided by 2 is going to be 22.5? 45 degrees. Ooh, I know how to do that. This is going to work out much better for me now. So the sine of 45 degrees over 2, I can deal with that. So I go into my sine half angle. Now sine half angle, both of these are over 2, so that's telling me that it's going to be a half angle. The only difference between sine and cosine is sine has subtraction right here and cosine has addition. So cosine's normal, and then sine is sort of the opposite, I guess, but it's not really the opposite. So we need to do plus or minus the square root of 1 minus the cosine of 45 degrees over 2. Now I'm going to deal with this plus or minus right away because we kind of just talked about it. I want to use the positive case because this 22.5 is in quadrant 1. I don't care about where 45 is, I care where 22.5 is. 22.5 is in quadrant 1, so I want to use the positive case because sine's positive there. So I'd like positive, please. So we get positive square root of 1 minus the cosine of 45 degrees. I can do that. That's the cosine of pi over 4. That's the square root of 2 over 2. This is all over 2. And then I say, hey, I don't want that fraction inside of my fraction. So I'm going to multiply top and bottom by 2. We get the square root of 1 minus the square root of 2 over 4. I can square root that numerator and denominator. So I get the square root of 1 minus the square root of 2 all over 2. Now you might look at that and say, ooh, I got a square root in a square root. Is that okay to leave? It feels like maybe I can't leave it like that. Guess what? You can. You can totally leave it like that. That's fine. Don't even worry about it. Square roots inside of square roots, sure, whatever. And we're going to leave it. We're going to leave it. And that's not just me kind of like hand waving. That's just like, no, we just don't deal with that. It's fine. It's fine. Square roots and square roots, totally fine. Tangent of 5 pi over 8. I never learned my pi over 8s, and I don't want to. But today's kind of our half angle day. I could potentially do this with double angles or half angles, but it's half angle day, so I'm going to do half angle. So I say to myself, okay, well, today's half angle day, so I want to do something divided by 2 to get me 5 pi over 8. Well, 5 pi over 4, if I divide that by 2, 5 pi over 4 divided by 2, that's the same as multiplying by a half, and it would be the same as 5 pi over 8. So that is going to be the angle that we're going to use. Now remember, there are 3 for tangent. One of them we hate, and the other 2, no, 2 of them we hate, and the other one is fine. Now, is it sine or cosine in the denominator for that thing? I believe it is cosine, but I don't mind taking a look at my identity sheet to verify. Good thing I checked. It is sine in my denominator, and in my numerator, I got 1 minus cosine. So I want to do 1 minus the cosine of my angle. Pi over 4. And then over the sine of that same angle, 5 pi over 4. Now notice that there is no little plus or minus at the beginning of this one, so I don't have to really worry about like, well, what quadrant is 5 pi over 4 in, or 5 pi over 8? Well, I don't have to worry about that. There is no plus or minus. You would have to worry about that in the horrible one, but we're not doing that, so don't do that. Cosine of 5 pi over 4, that's in quadrant 3 where cosine is negative, so it is going to be negative. Note that I switched the minus to a plus. Square root of 2 over 2. Over sine of 5 pi over 4 is also negative square root of 2 over 2. All right, we've got our answer. All we need to do now is simplify it. I don't like those divide by 2's, so I'm going to multiply top and bottom by 2. So I get 2 plus the square root of 2 over the negative square root of 2. I don't like that square root of 2 in the denominator. I am going to deal with that. So I'm going to multiply top and bottom by the square root of 2. So we get 2 square root of 2 times the square root of 2 times the square root of 2 is just 2. Plus, why did I say times? Over negative 2. Ooh, I can divide that. We get negative square root of 2 minus 1. And there's our answer.